All right, next up, we're going to look at what's called a resultant vector. A resultant vector, the definition, it is a single vector with the same effect as all other vectors combined. We use a big letter R to represent the resultant vector. So since we deal with a lot of vectors in physics, in this particular illustration, we're having forces that are acting. So in this illustration here, the vectors are forces. So we can use FR to represent the resultant force. So here's a very simple illustration. We're having two guys here. Person A pulling to the left with a force, and B pulling to the right with a force of 50 newtons. So they're pulling the same object here. So what we want to do is to find the resultant force that is going to act on the object here. So what we have to do is, since we are taking direction into consideration, these are vectors, right? We must take direction into consideration. We need to choose one direction as positive. So we can say take right as positive. All right, so it means that any vector which is acting to the right is positive, and any vector which is acting to the left would be negative. So this vector here is positive since it's acting to the right. This vector will be negative since it's acting to the left. And then we simply combine the two. So I'm going to say FR, which is the resultant force. This is going to be equal to force number 1 plus force number 2. Force number 1 is 50 newtons plus force number 2 is negative 30. 50 plus negative 30, that will give us 20 newtons. Therefore, the resultant force is actually equal to 20 newtons to the right. Okay, so I'm saying 20 newtons to the right because I've chosen right side as positive, and our answer is also positive here. If we had gotten a negative answer, it means that our force was going to be to the left. So what does this mean? What does a resultant force imply? Right, we use a resultant force to try to understand and predict the behavior of an object. So in this particular case here, we are saying that we can have this same object experiencing a force of 20 newtons to the right. If I have a force of 20 newtons acting to the right, I'll have pretty much the same situation as this one here. So I can replace these two forces with only one force acting on that particular object, and I'll have the same effect on that particular object. So that's what we call a resultant force. A single vector with the same effect as all other vectors combined together. Okay. If no force is acting on an object, our resultant force is 0. We don't have any applied force acting on these objects, but we do have the normal force and the weight of the object. They're acting there, but they're cancelling each other. So since you see here, I don't have a force acting on my object, it means the resultant force acting on the object is what? Is 0. So I have a 0 resultant force. So it is possible to have a net force of 0 acting on an object. Right. In this particular case here, if the net force is 0, right, if the resultant force is equal to 0, it simply means that our object will remain stationary, so it will remain at rest for as long as there is no resultant force acting there. Or if the object is moving, it will keep moving at a constant velocity. So this holds true for as long as there is no resultant force acting on your object. Okay. Right. If only one force acts on the object, then the resultant force will be equal to that particular force. For example, here where I'm having only one force acting on my object here, right? Since it's only this only force acting, it means that particular force is actually my resultant force. So my resultant force here is equal to 75 newtons, provided that there is no force acting in the opposite direction. So let's just suppose that this is no friction at all. So if it's very smooth, it means that this particular force here being applied on the object is actually equal to the resultant force, or the net force acting on my object. Okay. However, if we have more than one force acting on an object, then the resultant in this particular case would be the sum of all the forces that are acting on that particular object. Here's a very simple scenario here. I'm having two forces acting to the right. I have a 75 Newton force. I have a 90 Newton force. These are pulling to the right. To the left, I have a 100 Newton force and a 60 Newton force. Now, a question can say, calculate the resultant force acting on the box. So what do we do? I have to choose a positive direction. So I can say, okay, let me take right as positive, right? I'm taking right side as positive. It means that the 75 Newton force and the 90 Newton forces, this force is positive, this one will be positive. And the 60 Newton force and the 100 Newton force, both of these forces are what? Are negative. And then I'm simply going to add everything together to get my resultant. So I'll simply say FR is equal to force number 1 plus force number 2 plus force number 3 plus force number 4. This is going to be equal to, so let me take the positive first. So I have 75 plus 90 plus negative 100 plus negative 60. All right. Then I must simply sum everything here and see what I get. So I have 75 plus 90 plus negative 100 plus negative 60. So I get 5 newtons. And my answer here is positive. It's positive here, which means that it's to the right. 5 newtons to the right. That's the resultant force. This particular force has the same effect as all these other forces acting on my object. So it means that if I only have one force, the 5 Newton force, pulling the same object, I will have exactly the same effect on the object. My object will move with the same speed, it will have the same acceleration, provided that the surfaces here are just the same as well.